Hi, this is the Algebra 2 supplementary lesson on lesson 59C. We're converting rectangular form of a vector expression into a polar form, and this is the same type of problem as we were doing yesterday. I think the assignment yesterday focused on the opposite, changing polar to rectangular, and your homeworks today will do concentrating changing rectangular to polar. I did both in yesterday's video. Today I just want to do an area where I see just a minor trip up on a lot of you guys with recording the angles when we convert into polar form. Okay, so if we're going to change this expression of rectangular coordinates or rectangular vectors into polar form, okay, we know we need to express it in the terms of a distance and then an angle measurement in degrees to convert that. So what this stands for is 39.5 units to the right. Now I know most of your problems will have even integers. I just want to show you this is equally valid if we have decimals, okay? And so I have my graph expressed instead of one digits. These are 10, 20, 30. So I'm just going to kind of estimate 39.5 in the plus positive right direction will be 10, 20, 30, 9.5. It'll be almost here to 40. Okay, so somewhere like there. And then I'm down 15.2 units. So I'm going to go down 10, and about 15 is about halfway there. Okay, so my point will be somewhere here. So what am I wanting to find? I'm wanting to find the expression of that vector there from the origin down to this point, 39.5 units to the right, down 15.2 units. So I'm going to go ahead. This is my triangle. I set up my reference triangle back to the x-axis. Okay, so this distance is 39.5. This one is 15.2 on my triangle. Okay, the angle I'm going to use is the angle, the reference angle. I'm going to call it theta. You could use any one you want to do. Let's call it A. Let's not use that theta. Let's call it A. Angle A. Now that's always going to be back to the x-axis too. That is going to be our reference angle. Okay, so what we're going to do is solve for this, and I would recommend, if we're going to use your trigonomic functions, solve for your angle first. That's easy. What we have is we have the two leg lengths. We don't have the hypotenuse length. Okay, so we will use our tangent function. The tangent of angle A is going to be the ratio of the opposite leg, 15.2, divided by my adjacent leg, 39.5. Okay, to find that angle, to find angle A, I'm going to take the inverse tangent of that ratio, 15.2 over 39.5. Okay, that comes out to, when I do it on my calculator, 21.05 degrees when I round it off. Okay, so A will equal 21.05 degrees. A down here will equal. Will it equal 21.05 degrees? No. This is where the problem where most of you trip up. Okay, this angle represents the angle right here. Okay, in our reference triangle. Okay, the angle we use in our reference triangle when using the trigonomic functions is not the one we use for our graphing system most of the time, and I'll explain that in a minute. Okay, remember our angle measurements in the graphing system are based on starting at the x-axis here and going counterclockwise. Okay, I'm going to move over here and stand up real quick. So to record the proper angle for that, we need the angle that tells us what is our angle going around that way. Okay, well, we recognize it's not going to be 21.05. okay, the angle we need is going to be 360 degrees minus 21.05. Okay, because it's all the way around the circle except this 21.05 degrees. Okay, and when we do that, that comes up to 338.95. Okay, that is the angle we use here, 338.95. Okay, to record that angle because it's measured from our x-axis. Okay, so always step back and do that. Now, what I say most of the time, our angle for our reference triangle and our angle for our coordinate system do not jive. Notice, if we're up here in the first quadrant, okay, we're measuring angles, the reference angle that we use for any triangle, because if we establish a triangle, let me see if I can get a different colored piece of chalk here. I don't know if that green will show up. I'll try to use this orange. Okay, if we draw an angle up here, okay, and we draw our reference triangle back to the x-axis, we notice the measure of this angle here is going to be our reference angle. It's also going to be the reference angle from the x-axis. No problem in the first quadrant of our graph. If we have an angle out here though, and we draw our reference back to the x-axis, this is now our reference angle right here. Okay, we notice that is not going to be the same as our measurement angle. Our measurement angle starts here and ends right here. Okay, so we will have to take whatever angle we got from there and take 180 and subtract that angle to get this angle right here. Okay, if we're down here in the third quadrant, say we're down here somewhere, we draw our triangle back to the x-axis. Okay, this is our reference angle in the third quadrant. Okay, we notice when we measure an angle, okay, when we do that, we have to take 180 degrees plus this angle measurement to get our angle for the graphing system. Okay, and then again in the fourth quadrant, our reference angle ends up being here. Okay, so we have to take 360 degrees minus that to get the proper graphing angle, the reference angle for our graphing system. Okay, so hope that we went through each coordinate to show how that's different. So just keep track of where you are in the graph. Okay, rule of thumb, okay, if you're not up here in the first quadrant where both the x and the y are positive, okay, you're going to have to figure out a different angle than the one we use for our reference triangle for trig functions. Okay, any other quadrant than the first quadrant up here. Okay, so we have our angle. Let's go on to our distance. Need another piece of chalk. So what do we have? Okay, I'm going to go ahead and erase this information we had for determining the angle. Okay, so what do we have? We have a triangle here, a right triangle with a side length of 39.5 and one of 15.2. We're trying to find the hypotenuse, and we solved this angle here as 21.05 degrees. Okay, now we can certainly use the Pythagorean theorem if you would like. Okay, and when we go through and do that, the hypotenuse is end up being the square root of the sum of the squares, 39.5 squared plus 15.2 squared equals, okay, now I went ahead and did that on my calculator, and the first time around I got 270.54. Okay, and then I looked at that and I'm like, man, that's really long. Okay, we know the hypotenuse length should be the longest length in my triangle, but gee, 270 when this side is 15 and this side is 39, that seems a little long. And so what it is I have a weird way of entering the square root into my calculator. I have to hit the square root function and then put these items in under the square root function. But when I do that, I also have to put in extra brackets under my square root function in my calculator to make sure it does both of these under the square root symbol, okay? And I don't like doing that because why? Because sometimes I screw up and I get weird answers like this, okay? Now, if you're confident that you can do that and you know how it works in your calculator, okay, you do it. So I redid that because I'm like, man, that doesn't seem right. And then I did it again in a little bit different way, and I got this number, 42.32. And I was like, well, that looks a little better. Let's see what it ends up to be with trig functions, okay? I'm going to use my cosine function. The cosine of that angle, 21.05, is going to equal the adjacent leg length to that angle, 39.5, over the hypotenuse. To solve for the hypotenuse, I rearrange the equation. It's going to equal 39.5 over the cosine of 21.05 equals, okay? When I do that, 39.5 divided by, I hit my cosine button, I type in the angle, 29.05, I close it off, I hit equals, I get 42.43. Is that what I got on 3, 2, let me see that. 39.5 divided by cosine 21.05 equals 40. This should be 3, 2. I'm sorry. Typed something wrong there. I typed something in wrong there too, but at least I wasn't off by a factor of 10. Okay, my decimal point was off a little bit. Okay, but what I noticed when I do it, so what is this? This is my distance. It's my hypotenuse distance. That is the distance over here. I'm going to put in 42.32. That is my answer for that problem. Okay, but when I put it in this way, I only had like 5 or 6 calculator buttons to hit. When I put it in this way, I easily have double that. I have 10 or 12 calculator buttons I have to press to do the Pythagorean theorem. I don't like doing the Pythagorean theorem, especially on my calculator, because the square root function is really hard, I think, to work on this. So if I can avoid typing in square roots in my calculator, that's what I do. So I hope that helps. This is a common problem here that I've seen with doing that we record the wrong angle. A lot of you will put in 21.05. What is 21? Where is the angle 21.05? It's about right here on our graphing system. 21.05 degrees from the x-axis in a counterclockwise direction. That is not where this line lies, okay? So I hope that helps. Shoot an email or a text message with any questions. So long for now.